Question number 16. For an ion having single electron, following wavelength are observed in the emission spectrum. The missing wavelength X is. Now dear student, in this case, the wavelength is given 40 nanometer, whereas in this case you have to determine, and this is given 60. Now you know that this total energy change, that is from level 3 to 1, should be equal to from 3 to 2 plus energy from 2 to 1. And this energy is equal to hc by lambda, and that is equal to hc upon lambda from 3 to 2 and hc divided by lambda from 2 to 1. So 1 by lambda 3 1 is equal to 1 upon lambda 3 2 plus 1 upon lambda 2 1. Now what is given? This is given 40. So 1 upon 40 nanometer, 1 upon this x you have to determine, and this is 1 upon 60 nanometer. Now take on left hand solve, then you get x equal to 120 nanometer. And your correct option is the first answer. Let's go to question number 17. The ratio of the centimetal acceleration of the electron in singly ionized helium ion and hydrogen atom is. Singly ionized helium and hydrogen are identical in Bohr model. The centripetal acceleration, and that should be equal to v square by r. Now, for an electron, the velocity is proportional to z by n, and the radius is proportional to n square by z. Therefore, the centripetal acceleration AC is proportional to z by n square divided by r, and r is equal to what? N square divided by z. So A become proportional to z cube over n square. Now the acceleration ratio for helium and hydrogen, will be equal to z helium in the ground state, n is equal to 1, and z hydrogen divided by 1. So this comes to be z for hydrogen is equal to 2. So it is 2 cube divided by 1. So A helium to A hydrogen, and that is equal to 8. So correct option is answer 2. So let's go to the question number 18. A PN junction photodiode is fabricated from semiconductor with the band gap of 2.5 electron volt. It can detect a signal of the wavelength. These are 4 options. Now, the energy gap is given to be equal to 2.5 electron volt, right? And the wavelength requirement will be the lambda is equal to hc by the energy, and in term of electron volt, this become 12,400 divided by 2.5 comes to be 4960 angstrom. So all wavelength less than this will be detected, and the only option is 4000. So answer to this question is option number 3. In question number 19, the Boolean expression for the circuit shown in the figure is, this is a circuit given, and these are the 4 options. Now dear student, from A, if we take this your input, and this is a NOT gate. From A, you get A inverse, and from B, now these two combine here, it's an AND gate, so it's a multiply, so Y become equal to A inverse dot B. Look at the option. The option second is A inverse B. Therefore, the correct option is the 2. Let's move to the next problem. The input signal given to common emitter amplifier having a voltage gain of 150. The input voltage Vi is given 2 sine of 15t plus 10 degree. The corresponding output voltage is, these are 4 equations. Now dear students, you know that the voltage gain is the output voltage divided by the input voltage. Now voltage gain is given 150. The output voltage we have to search, whereas the input voltage from here is 2, and you get that output voltage is equal to 300 volt. Now it is a common emitter amplifier, and in common emitter amplifier the output goes 180 degree out of phase. Therefore, you get the additional phase of 180 degree. And see in the input equation was equal to 2 sine of 15t plus 10 degree. So output, the voltage become equal to 300 volt. 15t plus 10 is the phase. Now additional phase of 180 degree will come into picture. So therefore the output equation becomes 300 and sine of 15t plus of 190 degree. And your option number 3 is 300 sine of 15t plus 190 degree. So the correct option is option number 3.